In this second part of the lecture, we are going to look at the properties of cartilage. And also we are going to have a look at the 3 different tests that we can make to measure the mechanical properties of cartilage tissue. So cartilage, we are going to talk today specifically at the cartilage at the joints. So for example, the cartilage here at the hip, or the cartilage here at the knee. We have other cartilage tissues, for example, in our airways. So in our trachea, pharynx, and larynx, we also have cartilage that is going to keep the airways open, and that's very different to the cartilage in our knees. Cartilage in our knees is called hyaline cartilage. In comparison to the cartilage, for example, in the trachea or the meniscus, that is called fibrocartilage. And then we have another type of cartilage, for example, the one in our ears and the one in our nose, that is called elastic cartilage. So the difference between the 3 different types of cartilage, hyaline, fibrocartilage, and elastic cartilage, is the components. So the type of collagen, for example, collagen type 1 versus collagen type 2, collagen type 10, collagen type 5, and also to the presence of different proteins, for example, elastin, which is going to give our ears or our nose the elastic property. Okay. So again, we are going to focus today in the cartilage in the joints. So it's going to be hyaline cartilage. So this cartilage in the joint is also an anisotropic, similar to the bone, and is anisotropic not only because we have different components that are going to make the cartilage, but also because the components are organized in a very specific way. So we have different layers. So here we have the surface layer. So in the surface layer, the collagen is going to be organized here parallel to the surface of the cartilage, so parallel to the load that is coming from the bone, or perpendicular, perpendicular to the load, I'm sorry. And then here we are going to have the middle layer. So in the middle layer, the fibers, they are going to be arranged in a chaotic manner, okay? So there's not going to be this really nice alignment that we have in the surface layer. Then we have the deep layer. So in the deep layer, we are going to have, again, the collagen fibers aligned, but instead of being aligned in this direction, parallel to the surface, they are going to be aligned perpendicular to the surface. Okay, and finally, here we have the subchondral bone. And between the cartilage and the subchondral bone, we also have the tight line. Okay, so we have this specific organization of the collagen fibers in cartilage that is going to give the tissue specific properties, but also a part of collagen, we have other component that is really important for cartilage. So this component is GAG, or glycosaminoglycans. So glycosaminoglycans are these sugars or proteins associated with sugars that are really negatively charged, and they're going to store a lot of water. And that's going to give cartilage very specific characteristics that we are going to look in a sec. So GAG, or glycosaminoglycans. And we have different types of glycosaminoglycans. Important one will be hyaluronic acid. Then we have lubricin. So lubricin is going to lubricate the joint, so it's going to be on top of the cartilage, and it's going to facilitate that smoothness between the cartilage and the other cartilage for the knee. And another important one is chondroitin sulfate, for example. So these are really important because these GAGs, they are very negatively charged, and they are going to bind very strongly to water, so they are going to retain water. And this is the reason why the major component of our cartilage is water. So our cartilage is 65 to 85% water due to these gags. Okay, so let's continue with the different mechanical tests that we can perform to analyze the mechanical properties of cartilage. So the first test that we can perform is the creep test. So in the creep test, here we are going to keep the stress the same. And then we are going to measure the strain. So we are going to measure the deformation. So we're going to get something like this here, and we have different phases here. So the first phase here is going to be the liquid exudation phase, or fluid exudation. So this means that when we apply a force here on the surface of the cartilage, the water here that is contained in the surface is going to be displaced in this direction and be distributed in the cartilage, and also is going to leave the cartilage into the synovial area. Then the second phase that we have here is the collagen alignment. So in this phase, the collagen here is going to align and is going to reorganize. And finally, we have the final phase, which is the stabilization phase, in which the collagen doesn't realign or there is not any fluid movement. Okay. Then the second test I wanted to look at today is the stress relaxation test. So in this test, we are going to maintain the strain constant, and we are going to measure the stress. Okay. Over time. So what we're going to get here is something like this until it arrives to the maximum strain. And then due to this water content and to the presence of the glucosaminoglycans, then it's going to come back to its initial shape and is going to stabilize in a curve similar to this one. And finally, the last test that I wanted to look at is the failure test. So this is a test in which we compress the cartilage until it breaks. So the creep and the stress relaxation tests, we are not breaking the cartilage. We are just testing the mechanical properties of the cartilage without breaking it. But in the failure test, we are going to disrupt totally the cartilage. We are going to destroy it. So thanks to the failure test, we can see different characteristics here. So we are going to have the stress over the strain. So first, we are going to see this phase here, then something like this, and then we're going to arrive at a slope, and then it's going to go down when tissue fails. So here, first, we are going to see this viscoelastic region. So in this viscoelastic region, the collagen fibers, they are going to be disorganized, okay? Then we have a second elastic region. So in this elastic region, the collagen fibers, they are going to be rearranged and they are going to be aligned to each other. And here in the elastic region, we can calculate with the slope the Young modulus. Then we arrive to this valley here. So this is going to be our this slope here. So this is going to be the plastic region. So in this plastic region, the fibers are going to deform in the direction of the force. And finally, here we have the failure. in which the cartilage fibers or the collagen fibers, they are going to break, okay? Well, so today we have looked at an introduction of the mechanical properties, and then we have looked at the bone mechanical properties and the cartilage mechanical properties. I hope there is not a lot of information. I hope that you enjoyed today's lecture, and I see you in the next class. Thank you.